I actually came into engineering a little bit late. I started as a fundamental biologist, studying the brain and the development of the brain, and came to bioengineering because I hit a wall where I couldn't answer the questions that I wanted to answer. I sort of didn't think that I had the tools that would let me go deep enough into the biology.
I've taken the approach of saying, what are the fundamental discoveries that are out there, and can we implement them for patients?
Health Innovations via Engineering is about integrating engineering into health and bioscience research. Now, if you think about it, you wouldn't try and do medical or biomedical research without using biochemistry. But this is now the 21st century, and we have so many engineering tools that we can use. Engineering is now going to be as integral to health and biomedical research as biochemistry was in the last century.
So I study the immune system, and I think a lot of immunologists, they usually want to study one cell type, or they like to study things in isolation. I want to take a holistic view.
In my lab, what we do is build molecular machines that try to capture what's going on inside of a cell while it's happening and store it there, right? So these are sort of similar to tape recorders or cameras that actually operate within the cell. They store the information in DNA.
So I think that engineering is really uniquely poised right now to be able to help us get at previously unanswered questions that were just too complicated in biology. And that's why Hive is so exciting and why support from Hive is so critical in our work.
When I get together with these scientists who work on things that are completely different from me, I leave those conversations inspired and ready to try something new. I look at what they're doing and think about new ways to attack my problem using an engineering solution that actually unlocks the question and helps us come up with the answer.
So I brought the technology from semiconductor manufacturing to mimic the glomerular filter of the kidney and achieve the kind of filtration that you can only achieve in nature.
We're applying tissue engineering approaches to build human tissues outside of the body. The engineering approaches that we bring to UCSF and that we utilize in my lab really afford themselves well to the clinical resources that are available here.
The boundaries of what is engineering and what is biology and what is medicine have, I think, really gotten blurred. You know, how do you bring technical expertise of engineers who are kind of problem solvers, maybe not doing so much discovery research, but how do we learn things that can apply to actual real-world problems?
This is why it's so important to have engineers around, because engineers can bring into biomedicine the design component, the systems thinking, and the scale-up capabilities.
But sometimes there's a lot of learning and failure. And so we want to fail fast, and we want to be able to test these things so that we can make sure that we are at the leading edge of innovation in this space.
Health innovations.
Health innovation.
Health innovations.
Health innovations.
Health innovations via engineering.